Welcome everyone. We are discussing problems of inverse circular function. Today I will discuss some amazing problems of inverse circular functions. So these problems are important for competitive exam. I have already discussed you have to use here idea of other topics also. So look, problem number 1 and 2. X plus 1 whole square equals to x cube plus x equals to a by x bx plus c by x square plus 1. Then find value of cosec inverse 1 by a, cot inverse 1 by b plus sec inverse c. So second one also exactly same. 3x plus 1 by x minus 1 into x plus 3 equals to a by x minus 1 b by x plus 3. Find sin inverse a by b. So, application of integration as well as inverse circular functions. So, second one is very simple. We consider problem number 1. Now, so this is called method of partial function, fractions. So x plus 1 whole square, you know, if you take x common, this is x square plus 1. So linear and quadratic factor. For linear function, you know, you get a by x, and for quadratic functions, so this is bx plus. So that is why it is given in this form. Also, there is a restriction. The value of the degree of the numerator must be less than degree of the denominator. Here degree is 2, here degree is 3. So it is problem of method of partial fractions. Now you have to find A, B, C. Now this one, x plus 1 whole square equals to a into x square plus 1. So bx plus c into x. Bx plus c into x. So this is an identity. So we can compare coefficient of x square x and constant term and find a, b, c. Now, there is a factor x. So, if you put x equals to 0, then you get one constant directly. So, putting x equals to 0, so 1 equals to a. So, this is a, this one is 0. So, we are getting a. Now, you have to find b and c by comparing coefficient of different power of x. So comparing coefficient of x square, coefficient of x square. What is x square plus 2x plus 1? So this is 1, and here it is a, and this is bx into x. So a plus 1. Now we know a. What is a? A equals to 1. So this implies 1 equals to 1 plus b. This implies b equals to 0. So we are getting a and b. Now comparing constant term, this means coefficient of x to the power 0. So this is actually x square plus 2x plus 1. So what is constant term? This is 1 equals to a into 1. This is a. This is a. So we are getting a equals to 1, but we have already got it. So we are not getting any advantage. So you compare coefficient of x, comparing coefficient of x. So 2 equals to coefficient of x 2 equals to a into x square. So there is no x. So c into x. C into x. So ax square plus a, no x square. So bx square, no x square, cx only. So what is c? C equals to 2. So this is our main aim, to get ABC. Now we are getting ABC. So you have to find cosec inverse 1 by a. What is a? A equals to 1. So cosec inverse 1. Part inverse. What is b? B 0. So part inverse infinity plus sec inverse. Sec inverse 2. So cosec inverse 1. So sin inverse 1 is pi by 2. So this is pi by 2. This is pi by 2. Cot 0. Tan 0 is infinity. So cot 0. Cot inverse infinity. So this is cot 0. And sec inverse 2. That is cos inverse half. This is pi by 3. Now if we simplify, so this is 6 LCM, 3 pi plus 2 pi, 5 pi. So 5 pi by 6. So correct option is 5 pi by 6. So look, actually it is problem of integration. So using method of partial fraction, we are getting ABC. Now putting value of ABC, we are getting cosec inverse 1. So this is sin inverse 1. So cot inverse infinity, that is tan inverse 0 is 0, sec inverse half. So we are getting 5 pi by 6. So this is mixture of integration and inverse circular function. So most interesting. Now second one is exactly same. So this is simple. So this is denominator is product of two linear factor. So you are getting 3x plus 1 equals to a into x plus 3 b into x minus 1. Second one. So it is already given. So now you are getting two factor. So x equals to 1 implies 4 equals to 4a. This equals to 0. So you are getting a equals to 1. Now x equals to minus 3. If you put x equals to minus 3, so this implies minus 8 equals to. So this one is 0. So b into minus 4. So this implies b equals to 2. So it will take minimum time. You know, a quadratic expression is not occurring. For linear factor, it is very simple. So sin inverse a by b. So sin inverse, what is a? A1. So this is pi by 6. So this is, option is pi by 6. So it is also pi by 6, option number B. So this is combination of method of partial fractions and inverse circular function. But very simple problem. Now I consider one more problem of competitive exam. Problem of JEN and JEE Advanced also. So sin inverse x minus x square by 2 plus x cube by 4 dot infinity equals to cos inverse x square minus x4 by 4 plus x6 by 6 x6 by 4 dot infinity equals to pi by 2. And x lies between 0 to root 2. Then which option is correct option? So look, we know. So what is our working? Sin inverse x plus cos inverse x equals to pi by 4 equals to pi by 4. So here relation is sin inverse x plus cos inverse x equals to pi by 2. So this relation will be true when this argument and this argument will be same. So this argument and this argument must be same. So therefore we are getting x minus x square by 2 plus x cube by 4, and this is x square minus x4 by 2 plus x6 by 4 dot dot infinity. Now it reduces to problem of algebra. So take x component, 1 minus x by 2 plus x square by 4 dot dot infinity. So x square 1 minus x square by 2 x4 by 4 dot dot infinity. Now look, this is 1 minus x by 2 x square by 4. So look, ratio minus x by 2, this by this minus x by 2, ratio x square by 2, here also minus x square by 2, here also minus x square by 2. So this is infinite GP series. So what is the formula? Is infinity equals to a by 1 minus r. A equals to first term, r equals to common. So x into, what is a? First term is 1. 1 minus, what is r? R is minus x by 2. Then x square unchanged. So 1 by 1 minus x square by 2. This is common ratio. Now one restriction is given, x not equals to 0. So you can cancel x. So 1 plus x by 2 equals to x by 1 plus x square by 2, x not equals to 0. You can cancel x. So this implies, if we multiply x plus x square by 2, 1 plus x square by 2, this implies x equals to 1. So what is restriction of x? 0 to root 2. So 1 lies inside the interval. So we are getting solution as x equals to 1. So B, option B is x equals to 1. So this is also mixture problem. So inverse circular function and series, actually infinite GP series. So most interesting problem. Now I consider one more problem, problem number 4. If small m and capital M be the minimum and maximum value of fx equals to tan inverse sin x plus cos x in 0 to pi by 2, then value of tan capital M minus small m. So you have to find maximum and minimum value of the function. Now what is fx? Fx equals to tan inverse sin x plus cos x. Now f dash x equals to 1 by 1 plus sin x plus cos x whole square into cos x minus sin x. Now f dash x equals to 0 implies cos x minus sin x equals to 0. cos x minus, because denominator is non-zero, 1 plus square term. This is non-zero. Denominator not equals to 0. So we are getting cos x equals to sin x. So tan x equals to 1. So x equals to n pi plus pi by 4. Now, so we are getting pi by 4. We are getting only 1 point, pi by 4, in the said restriction. In the said restriction. In 0 to pi by 2, we are getting only 1. So what are the points? So we have to check maximum. We have to check for maximum and minimum value 3 points. So at the end point and at x equals to pi by 4. So we are not considering local maxima or minima. We are considering also absolute maxima and absolute minima. So x, then fx. So at x equals to 0, so at x equals to 0, this is tan inverse 1. Cos 0 is 1. So this is tan inverse 1. And x equals to pi by 4. This is 1 by root 2. This is 1 by root 2. So tan inverse root 2. And for pi by 2. Pi by 2. So this is 0. This is 1. So tan inverse 1. So this is maximum value. So what is m? We are getting m equals to tan inverse root 2. And what is small m? Small m is tan inverse 1. Now m minus m equals to tan inverse root 2 minus tan inverse 1. So this is tan inverse root 2 minus 1 by 1 plus root 2. So our aim is to find tan capital M minus small m. So tan inverse absorb root 2 minus 1 by root 2 plus 1. So root 2 minus 1 whole square by 2 minus 1. So 3 minus 2 root 2. So value is 3 minus 2 root 2. So this one is 3 plus 2 root 3. So this is not our correct option. Correct option is none. So 3 minus 2 root 2 will be correct option. Now this is one method also. You can also find maximum and minimum value. Try to recall by expressing it. This is tan inverse. This is root 2 and 1 by root 2 sin x. 1 by root 2 cos x. So you know this process. You have to divide throughout by a square plus b square. a1 b1. So tan inverse root 2 into this is sin x plus pi by 4. Now a maximum equals to tan inverse, this is 1, so root 2. Tan inverse root 2. Now a minimum is, this is minus 1, so tan inverse minus root 2. But here one condition is given. X lies between 0 to pi by 2. So x plus pi by 4 lies between pi by 4 to 3 pi by 4. So that is sin x plus pi by 4 equals to positive. So we cannot take this one as minus. So what is a minimum? So it is obtained when we put x equals to 0. If we put x equals to 0, this will be tan inverse root 2 into 1 by root 2 tan inverse 1. So this is capital N, this is small n. You can also use this method also. So this is most interesting problem. So today I have discussed 4 problems, 4 mixed problems of inverse circular functions. They are most important for competitive exam. So thank you for today.